Hi, today's podcast is going to be about observations and inferences. These are two tools that scientists use all the time, and it's going to be really important that we iron out the difference between an observation and an inference. For a warm-up activity, in a moment I'm going to come around to your table and I'm going to tell you when it's your turn to get up and walk to the front of the room. You're going to walk around the cube that's on the front desk, and I want you to make some careful observations of what you see on the sides. Using the information you see on the sides of the cube, I want you to draw on your papers in the box what you think is on the bottom of the cube. You may not touch or move the cube in any way. An observation is the gathering of information using your five senses. So just now you used your sight to make observations of the stuff that was on the sides of the cube. You could also make observations using smell, hearing, taste, or touch. There are two types of observations: qualitative and quantitative observations. So a qualitative observation is when you describe what you observe. So quality is the root of the word qualitative. These observations use adjectives to describe something. Two examples would be the flower has white petals and Mr. M has blue eyes. Those are both describing qualities of an object. You could also describe qualities of a phenomena. For example, you could say the explosion was big. I want you guys to practice now. Please make two qualitative observations about this picture. Quantitative observations measure what we observe. Quantity is the root of quantitative. These observations use numbers to measure something in a quantitative way. So again, we have the same white flower in the corner of the picture. If you're going to quantify the petals on the flower, you'd say the flower has 7 petals. Mr. M has 2 eyes would be another example of a quantitative observation. I want you guys to practice. Please make two quantitative observations about this picture. So which type of observation is better? They're both valuable in science, but in an experiment, sometimes it's more useful if you make a quantitative observation about the results, because it can be precisely and objectively compared to a different object or a different phenomenon. For example, pretend like you have a biker and you have a driver. If you said the road is long to the biker, that might mean something completely different to the driver. But if you said the road is 5 kilometers long, that would mean exactly the same thing to both of those people. Long can be interpreted in different ways, but 5 kilometers long means the same thing to everybody across the board. Some things are easier to quantify than others, so scientists have come up with some innovative ways of turning qualitative observations into quantitative observations. I'm going to use this dead fish as an example. Suppose we were studying this dead fish and someone said, hey, that dead fish is smelly. But if you're going to compare it to a different fish, smelly might mean different things to different people, so it's difficult to know exactly what smelly means in this context. One of the ways that scientists have come up to quantify results and quantify observations is you can use a rating system. You've seen this when they talk about movies, like a 5-star movie versus a 2-star movie. Hotels, restaurants, lots of different things use a rating system. So you could also put this fish on a rating system and say, rate the smelliness of the fish on a scale of 1 to 5. The trick that scientists use is they need to determine what is a smelliness of 1 and what's a smelliness of 5. And everybody has to understand the scale in order to make an appropriate rating of the smelliness of this fish. So maybe a 1 would be, you can barely smell it, and a 5 would be a totally knock you on your butt stink. So what do we do when we can't directly observe something? And we use this technique all the time in our lives. Sometimes we come to a conclusion using logic instead of direct observation. When you come to a conclusion based on logic instead of observation, it's called an inference. So how did you decide what was on the bottom of the cube? What clues did you use to come up with the best idea? You used an inference to come up with the stuff that was on the bottom of the cube. It's sort of like saying an educated guess. But an inference can also be an explanation for an observation you've made. It can also be based on your past experiences and prior knowledge. Maybe you've seen a dice before. Maybe that helped you come up with the large number that you think might be on the bottom. Inferences often change when new observations are made. If we learn something new, we have to change the way we think about the world to integrate that new idea. And again, just to reiterate, observations are information we gather directly through our five senses. So you saw what was on the sides of the cube. That's direct observation. So here are some examples. The grass on the school's front lawn is wet. So we can make an inference to explain why the grass is wet. You probably have some really good and logical ideas as to why it might be wet. Let's pretend like you didn't see the grass get wet, so you didn't directly observe any one of these explanations. It could be that it rained overnight. That's logical. It's based on your prior knowledge. You've seen it rain before. The sprinkler might have been on. There is dew on the grass from the morning, or a dog peed on the grass. These are all things that could have possibly happened, and again, you didn't directly observe them happening. So if you're explaining the fact that the grass is wet with maybe the fact that it rained, you're making an inference about why the school's lawn is wet. So here's another example. The school's fire alarm is going off. Remember, you're sitting in the classroom, you're not observing directly why the school's fire alarm is going off. But let's think of some possible inferences about why that fire alarm is going off. Perhaps the school is on fire. Perhaps we're having a fire drill. Perhaps a student has pulled the fire alarm. These are all logical explanations for why the fire alarm is going off, and you didn't directly observe them, but they're good reasons for why it might be going off. And the last one, I'm going to let you do this one on your own. A student is sitting in the main office. Please tell me 3 inferences about why that student is sitting in the front office. And this is the last part of our activity. I want you to write 3 statements about the cube. Use these sentences that have the blanks to help you form your ideas. I want you to use this format. And I want you to fill in this information with things that you think are real. So I think the cube has blank on the bottom because blank. Perhaps you said, I think the cube has a 7 on the bottom because I see a 4, a 5, and a 6 on the sides. Maybe you don't agree with me. You should write your own. And that's it for our podcast today.